Alright guys, welcome back. Today, or on this video, we're going to be talking about neutralization. So, we saw earlier, acids are chemicals that react with water to form H3Os. How do they do that? Primarily by releasing H pluses. And we saw that bases form OH minuses. And so if you look at these two components here, they're going to form two water molecules. Whatever's left inside is going to form what we call an ionic salt, or just salt in general. I know that most of you guys are thinking, okay, yeah, I know that salt is NaCl. That's table salt. That's one kind of salt. But all ionic compounds are classified as salts. So NaCl is a salt. It's one of many. So let's jump into some examples here. Let's do simple acid. So HCl and NaOH. So first thing we have to understand, HCl and NaOH, we know that HCl ionizes, and it's going to react with water to form hydronium ion. What's left? Cl minus. NaOH is going to dissociate. Remember, ionic compounds dissociate. And it's going to form Na plus and OH minus. First thing we want to do is take care of our acid-base neutralization. Here is the part of the reaction that is being base. Here is the part of the reaction that is being an acid. Therefore, OH plus, OH plus, that's not right. We got to fix that. That's an OH minus. OH minus and H3O plus, this is going to take an H plus from H3O plus. That means H3O plus is going to lose a hydrogen and become H2O. And it'll lose its plus charge because it's losing an H plus. So it just becomes water. And this OH minus is getting that H plus, which means that the number of hydrogens it has goes up by 1, and also the charge goes up by 1, which means it forms another molecule of H2O. So we form two H2O molecules. What's left in the reaction? Well, we got our chloride ion, and we have our sodium ion. So these appear to be in the exact correct proportion. There's one of each, and one's a plus one, one's a minus one. So yeah, in this case, we are actually making NaCl. NaCl aqueous. So there is an acid-base reaction. As long as you understand that bases are always going to form OHs when they're in water, and you understand that acids are always going to make H3Os when they're in water, these reactions end up being very, very simple. So let's take a look at another example. I'm going to use a different acid this time. So I'm going to have HNO3, that's nitric acid. It's actually another one of the acids we classify as strong, which I will be covering in a video right after this. And let's say we're combining it with, I don't know, let's do another simple one. Let's do Magnesium hydroxide. Boom. That's a really terrible error. Let's fix that. So we'll do another reaction. There we go. So first of all, we have to talk about what this is going to form. And remember, our nitric acid is going to be forming hydronium. What's left? Nitrate ion. Here we're going to be getting magnesium ion, that's Mg2+, and we're going to have two OH-, two hydroxides. Why 2? Because there's a 2 in the subscript after the bracket. So we're going to need to do a quick little balance job on this, but again, it's not terrible. If I look at the counter ions, the Mg2+ and the NO3-, I notice that I'm going to need 2 of these. The only way to get 2 of these is to throw a 2 out front. So now this is balanced. So let's look at the H3Os and the OHs. So I have 2 H3Os here, and I have 2 OHs, which means both of these H3Os are going to give away a hydrogen to our OH- and make water. So that means we're going to end up with, between these, 4 molecules of water. And then what's left in the reaction? Well, we have an Mg2+ and 2 nitrates. Those are balanced out charge as far as their charge. So MgNO3 bracket 2. And that is aqueous. So there is our acid-base neutralization reaction. Let's look at a slightly more difficult one that involves ammonia. So let's talk about our buddy ammonia, and let's say that we are mixing it with, we'll go back to our good old standby hydrochloric acid. So we've got our ammonia, we've got our HCl, we have to talk about what's being produced. So I know for a fact my HCl is going to make hydronium ion and chloride ion. These are both aqueous. Now I got to talk about what's going on with this guy, and you might not remember. If you don't remember, please watch the previous video. So we're going to have NH4 plus and OH minus. Remember, this is a reaction with water. Where did the OH come from? It was the leftovers from a water molecule. The sweet thing about this, though, is it actually like cleans up nicely. So here's our H3O. That's what's going to give our acid its acid character. And here's our OH minus. That's what gives our base its base character. So that's going to give us 2 water. And then what's left? NH4 and Cl. So NH4 Cl, aqueous. So really, this is as complicated as acid-base neutralizations get. Might we ask you to do, to do questions where we're talking about ions instead of straight up ionic compounds? I mean, we could. So let's take a look at one of those. So let's do a really simple one. Let me see what ions I want to play with here. So let's do, oops. Something like this. So these are still, this is the ion that we know of is responsible for being a base, which means that this must be the ion that's going to behave like an acid. And it does. So if we look at this H here, it's at the start of our formula. And when you have an H at the start of the formula like this, with a polyatomic or an ion at the end, and I know it's not technically an ion yet, but you know, that means that this is going to react with water to form H3O plus. What's left over is going to be SO4, 2 minus, and here we're going to have OH minus. Here's our OH minus, here's our H3O plus. That's going to give us 2 H2O molecules. And what's left is going to be sulfate ion. What does that mean for us? It means that whatever hydroxide we're talking about, this obviously has to have another ion along for the ride, some kind of positive ion. But when you deal with these as ions, you're going to have something left over that's got a charge. So it seems awkward, but in this case, it's okay. And also, if you look, the charges end up being fully balanced out. We've got a negative and a negative, so we've got an overall charge of 2 minus here. We've got neutral and 2 negative, so we have an overall charge of 2 negative here. So the charges, they still balance out regardless, which is nice. So I hope this helps you understand the concept of the neutralization reaction. Remember, it's very simple. It's an acid giving H3O, mixing with a base that's giving OH, forming water molecules, and whatever's left. If you have a positive ion and a negative ion, they're going to come together to form an ionic compound that we commonly just call salt.